In this video lecture, we're going to talk about two new types of inheritance: multiple inheritance and mix-in inheritance, which is also called composition. And a good source of notes for this, or references for this lecture, is the different types of inheritance in other languages as part of my notes. Also, Scott, if you have the book, has a special section on disk. I believe it's chapter 9.5 that gives some details about multiple inheritance in different languages. So we're going to start with multiple inheritance, and it's not supported by many languages. C++ is actually one of the few languages that does support multiple inheritance. So C++ does, but Java does not, and they decided that it was too complicated to do it, and they used interfaces instead in an effort to allow a class to implement multiple interfaces, but they decided you could only actually inherit implementation from one class. So let's start with why you want to provide multiple inheritance, or why you would want to use it. The first reason is because you want to provide more than one view of an object. Okay, for example, you might have a class stack list, and you want it to have the interface for both a list and for a stack. The way you could do that in C++ is by providing a comma-separated list of superclasses. In Java, you would do that by saying stack list implements list and stack. And in that case, list and stack have to be interfaces. They're not superclasses. So the first reason is you're basically inheriting interface. So we'll put up here inheriting interface. Second reason is you might want to inherit implementation from more than one class. Okay, up above here you probably don't want to inherit both the implementation from list and stack, because there's a good chance they conflict with each other. The stack might use an array or vector, the list might use a linked list, so you really don't want the implementation of both. But let's say, as an example, that you have a class, let's say people, and another class, say list, and now we want to create or let's say list node, and let's say we want to create a class student that is going to be a subclass of people, and we want the implementation for people, but let's say in addition we might want to put the student on a list. So we might decide we also want to inherit from list node, because now we can put the student on a list. Maybe it's going to be a list of freshmen or a list of sophomores, whatever, but we want to have both list node and people's implementation. So that's the why of why we use multiple inheritance. Well, what issues does it pose? There are problems, many problems with multiple inheritance, and that's why it's often not used anymore. So the first problem is duplicated names, or duplicated instance variables or methods. So what happens if your two superclasses both have the same name for a method or for an instance variable. So as an example, let's say we have class fruit, and I'm going to use pseudocode right now. Let's say that it has a value int calories and a function debug print. Again, I'm going to be using pseudocode here. And let's say I have a class veggie, which also has a instance variable for calories and a function named debug print. And finally, there's certain things that we tend to think of as both a fruit and a veggie, like a tomato. So let's say that we just create a generic class called food, and we want it to inherit from both fruit and from veggie. The question is, what do we do with our duplicated names? And the answer is that we are going to have to prefix the names with the class. So if we have, for example, a constructor for fruit, and let's say we just have the contribution from the fruit calories and the veggie calories, then if we wanted to initialize the two, we would need to say fruit calories colon for fcal, and we would do the same. We would say veggie, and I'm going to run out of space here, but we would say veggie colon calories and vcal. So you can get at the different instance variables or the different methods by prefixing the superclass names or prefixing the methods with their superclass names. Now what happens with debug print? Well, we're going to have to provide our own implementation for it. We can't just by default get it from our parent because it's ambiguous where we would get it. So if we just wanted to use fruits debug method, we could do it like this. So now debug print would look like fruits debug print method, or if we wanted to be like veggie debug print, we would replace fruit with veggie. Or if we want both to get called, we can do that. We could put that here, and now both debug print statements gets called. But the bottom line is you have to provide a implementation for all duplicated names or all duplicated methods. Have to provide an implementation. Okay, a second problem that comes up is what happens when one of the duplicated methods is a virtual method. Let's make it even worse. Let's say that it is a pure virtual method, meaning it has to be overridden. Yet we can't, because the method that we provide is going to be for this class. So for example, let's say that debug print had been a pure virtual method for veggie. It does us no good to define debug print in food because that method is associated with food, and the C++ compiler will still give us an error message saying we need a declaration for veggies debug print method. This is way complicated, so I'll just say brutally complicated. There's a way to do it. It's in my notes, comes up rarely, and we're not going to discuss it. But you should know that duplicated methods that are virtual methods are very difficult to deal with in multiple inheritance. Okay. The third thing is what happens when we have multiple inheritance from the same base class. So I'll say inheritance from the same base class. You're thinking, wait a minute, how can that happen? Because you have, for example, student. Let's say that student inherits from both people and from a list. Okay, you say, well, I don't have two instances of people. That's dumb. You might want two instances of lists, right, if it's going to be on two different lists. That's not actually even what we're concerned about here. Let's say we have another one, professor. And it also inherits from people. And this was actually list node over here, so we'll make it list node here too. Okay, and now let's say we want to have some professors that are also students, so we maybe have a student professor class. Now you might be able to see that we are inheriting from the same base classes. That we are inheriting from people and we're inheriting from list node. So what do we do in this case? Well, first of all, we got to think about, do we want two different versions of the base class? Well, for a list node, the answer is probably yes, because the student goes on a different list than the professor. So we probably do want two instances of a list node. But for people, the answer is no. This is the same person. It's not two separate people. So in the case of the people base class, we only want one copy, but in the case of list node, we want two copies. And there's a name for this: replicated inheritance versus shared inheritance. So replicated, you inherit separate copies. That's what we want with a list node. So we inherit separate copies from both branches, separate copies of the base class from each, I'll call it, chain. Whereas with shared inheritance, we get that we inherit a single copy of the base class. Okay, so list node here would be replicated, would use replicated inheritance. People would use shared inheritance. And how do we do this? How do we specify whether we want to use shared or replicated inheritance in C++? Well, by default, replicated inheritance is the default. So replicated is the default. So how do we get shared? We do that by specifying that the base class is virtual. So when we declare a student, we have to think ahead actually to when we actually declared a student. We would actually say public virtual person. Whereas we just say public, say list node. And now that says that when we later say class student professor, and we say public student, we are now having shared inheritance where we're going to share the base class with the professor. And you need to be consistent here. So professor, you are going to also need to declare the person to be replicated. If you don't, now it just gets even more complicated. I don't want to go into it. You just need to make sure that you're consistent. If you want shared inheritance, then each of the superclasses need to declare that base class as virtual. So that finishes the issues with multiple inheritance. It also introduces implementation issues that we are not going to be going into. Instead, we're going to move on to something called Mixin Inheritance. And we also often refer to it as composition. And Mixin Inheritance means that we want to inherit from one real, we'll say one real base class and an arbitrary number of interfaces. And what this really is saying is we want to inherit implementation. So we can really say we want to inherit implementation from one real base class and then our interface from an arbitrary number of interfaces. So that's often called Mixin Inheritance. And in C++, the way we can do that is we can make the so-called interface classes be abstract base classes. So you would make sure that every class in the, or every method in the class was pure virtual. So in C++, the way we do it is an interface is going to be an abstract class. Where every method is pure virtual. In contrast, in Java, you're just going to use interfaces. So that's one side to Mixin Inheritance, but here is a second side. Suppose that I wish to inherit behavior from multiple classes. Okay, but not the interface. Or that I want to even inherit a single. So I may want to inherit a single object's behavior. But not its interface. Okay. This first one comes up in Java because we don't have multiple inheritance, so we can't inherit behavior from multiple classes. The second case comes up in both C++ and Java, where it's not always the case that we want the interface. We've come across this example when I went through the inheritance lecture and I talked about a rectangle and a square. And we often want to inherit a rectangle's implementation. It has plenty of things that we may want, like get area, say contains point, say its draw method. These are all functions or behavior we would like to inherit. But there's parts of its interface that we don't. We do not want to inherit setWidth. Okay? We want instead to have something called setSize. And we do not want to inherit getWidth. We want to instead just have an interface called getSize. So this is an example where we really cannot make square be a subclass of rectangle because it does not want to inherit rectangle's interface in its entirety. But we do want rectangle's implementation. The way we can do this in Java is we're going to use a technique called composition. And you can do this as well in C++, although there's another way we're going to show you to do it in C++. So composition means that you create an instance of the object that you want to inherit behavior from and include it as an instance variable. So we would say, for example, class square, and it would have an instance of a rectangle. Perhaps that's where we keep the data. So this is Java now. And now where we want to re-export the interface, let's say with the draw method. So with the draw method, we just want to use rectangle's implementation and we want to export the draw method. We would just say data.draw. Okay? And in cases where we did not want to re-export it, we could define our own method. So let's say we have setSize. So you might imagine that's going to have to change both the width and the height of the rectangle. So then we can say set width of the rectangle to be the size, and we can set the height to also be the size. So now we've inherited, in some sense, the rectangle's implementation. We didn't have to rewrite it, but we didn't have to export that interface for set width or set height. We were able to use our own. So this technique comes in very handy when you want to inherit an object's behavior or a class's behavior without inheriting its interface. So this composition is an example of a commonly used design pattern in the real world. Now in C++, you do not actually have to use composition. You can actually change the way you declare the subclass. So I could say class square, and now instead of saying public, I can say protected rectangle. And it's saying, okay, I want to inherit rectangle's implementation, but anything that was previously public becomes protected. So now the interface that rectangle had goes away because everything in rectangle becomes protected. And you may say, well, wait a minute, I would like to re-export some of those methods like getArea, draw, and contains_point. The way you can do that is with something called the using keyword. So you could say using rectangle : draw. And now that re-exports the draw method. Similarly, you could say using rectangle : getArea, and getArea now becomes a re-exported public method. Whereas setSize, you would still provide your own method for it, but now you could because you're actually getting a hold of Rectangle's implementation, you could directly set it, the instance variables, because you directly have access to them. So this is the C++ way of inheriting from multiple, inheriting behavior from a class, but not its implementation. And you could use the same technique in C++ if you want to inherit from multiple classes by simply giving a comma-separated list up here. In Java, you can get inheritance of behavior from multiple classes by simply providing multiple instance variables, each of which represents an instance of an object from the class you want to inherit its behavior.